Buddy, and welcome to another Into the Terminal. Today, we're going to be talking about 5 security technologies you should be using now. Yeah, maybe 6. um, so, a lot of these, or actually all of them, come with Red Hat Enterprise Linux, but some of them you may not have seen before. So, Nate, why don't you start us into the terminal, and we will actually take a look at our first one, which is session recording.
Yes. So I know we said into the terminal, but I'm going to configure this using Web Console just to be honest, because it's really easy to show and really easy to demo. You can do this without Web Console, and we'll show you what the config file looks like in a minute. But basically, within the Web Console, there's a plugin you can install. I think it's just called Session Recording, and it'll look kind of like this. And you can see I've got no sessions. I've also got no configuration in place. If I click this little gear button up here, this is the configuration that I can set for session recording. Now, all I'm going to do in here is enable it. The way you enable it is under the SSSD config right here, which depending on the size of your screen will either show up over here where I've got it or down at the bottom. So just keep that in mind. I'm going to switch this to all. And you'll notice that I can exclude users or groups. So if there is for some reason that you do not want to record a certain group of users or a certain set of users sessions, you can do that here. I'm not going to do that because in most cases, I'm going to say you're probably going to record everybody. Otherwise, kind of what's the point? Like having an out seems like a bad idea to me. I'm sure there's reasons. Maybe you don't want to record root, for example. I don't know. Okay, so now that it's on, let me switch back over here. Look at that, fluid. It's like we've done this before. So now I'm actually at the console on the system that I just turned the session recording on. Let me find my my commands here. So what I wanted to show you was the actual configuration that we just put in place. So there's a configuration file that I'm just going to copy out of my notes, paste in here. It's called etsy sssd conf.d sssd session recording.conf. And this pretty much shows you exactly what we just told Web Console to put in place. And this is telling me that session recording scope is all, exclude users none, exclude groups none, right? Exactly what we just saw within Web Console. There's another config file that lets you configure the session recording parameters. Not who to record, but how to record, right? So that is this file. And the file, since you probably didn't see because I hit enter too quick, is etsy tlog tlog-rec-session.conf, right? Now, the reason I wanted to open this up in an editor, not just cat it, is because all those other config options that you saw in Web Console lets you configure this file. But if I do it through Web Console, it puts it into like a really munged, like not easy to read configuration. So I wanted to show you the config before we changed it with Web Console because it has all these nice comments and stuff in here. And all I'm going to do is change this line here. It's line number 12. It tells it to include a notice when a session is being recorded. Now, maybe you want to include a notice, maybe you don't. This is why it's configurable. I think for legal reasons, maybe you are supposed to include a recording, but I don't know. Maybe that depends on your industry and what you're doing. But we're just going to save that. And really, just that quick, it'll take effect, right? So the next time a session starts, SSSD will call Tlog and it will record the session, right? So what we're going to do is we're going to start a session. We're going to use SSH just because, you know, that's kind of a common way that you're going to be connecting to systems. Rel at localhost. Now, obviously, most people don't SSH to localhost, but bear with me. This is a demo. I'm going to put in our password, and you can see right there, look, attention, your session is being recorded. Now, I'm going to clear the screen, and then we're going to do something totally not nasty like cat etsy password, right? Or maybe I'm going to try to cat etsy shadow. Oh no, the hacker has been thwarted. Okay, now I'm going to log back out again. Okay, now you might say, big deal. You didn't actually stop that guy from doing anything. But what we have now is a recorded session. So what I'm going to do is go back here We're going to go to, hold on, switch tabs. I'm going to go back to session recording on my web console. You see it doesn't show anything. That's just because I need to refresh the page so that it shows sessions. And that's really only because I already had the tab open. If I went to the tab fresh, it would show me the sessions. And now right here, you can see I've got a session. Right? If I hit the play button here, it's going to show me that session and what happened on that session. Now, I realize this is probably hard to read on stream, but I just want to give you the concept of what this looks like. So you look at that right there. I'm catting a file, right? Now, obviously, not everybody's going to have web console installed. And like I said, it'll be easier to read if I do this over here. If we switch back to my terminal, the sessions are recorded via, they're in the systemd journal. I'm going to show you that quick. We paste this in here, journal CTL-O verbose. We're going to grep for the term recording, or rec, right? And you can see right here, it's got recordings done, right? Now, the recordings, you can actually, if you really wanted to, look at the output and the commands right here in the system journal. But that's not exactly pretty. Here you can see, look, I ran cat on Etsy Shadow, and it told me permission denied, right? But again, not pretty. So what you can do is you can take that recording ID, right? And you can put that in through a thing called tlog-play. Now, I have a concocted nasty regular expression here that I didn't come up with, but it's in our lab. If you want to go do our Tlog lab, this is directly from that lab. I'm not even going to attempt to tell you what all this is doing, except that it is in fact getting the same recording. It's cutting out some characters. It's getting exactly the piece that we need, and we're going to hit enter, and it's putting it all through Tlog-play. And you see, it brought me to a shell, right? Well, it's not a shell. This is a recording of the shell. You can see, remember I cleared the screen at the beginning? It just cleared the screen. Now it's catting Etsy password, which succeeded. Now it's going to cat Etsy shadow. Nope. No, you can't do that. And then it's going to exit. And then, of course, it exits the Tlog-play. Now, this is really useful in environments where you need to know what users are doing, right? Maybe you just want it for, who broke the system at 2 in the morning. Well, look for sessions that happened at 2 in the morning and see what happened. Maybe you want it to be able to tell who is trying to do something naughty on your system. Maybe you just want it for accountability. Maybe you need it for compliance reasons, right? But that's exactly what this is here for. And there we go. That's the demo on Tlog.
So a couple things. One, Nate, what software did you install to get this ability?
Sure. Let me go back to my notes. I'll give you the exact package names. So the web console plugin is called cockpit-session-recording. And then the packages that make Tlog work are just called Tlog.
Yeah, and if you install the web console package, it'll pull in the Tlog ones as dependencies. The other thing is this is stored, you mentioned, in the journal. That's actually a change. Previous releases of RHEL, I think, stored that in no, they always stored it in the journal, but you can store it in rsyslog as well. And then they're stored as logs. So you can also, if you have your rsyslog set up, you can send it to a remote logging server so that you don't have to worry about somebody manipulating things on the local machine. You actually have it stored remotely as well. And you can also do playback on that remote machine because it's stored in its logs. So you can use Tlog against the log files that have been collected from various systems to look at what's going on. The last thing I'd like to point out, which is really handy, is you get to see not only the history of commands that get run through your recorded session, but you get to see the output and error messages displayed on the session to the user. So a lot of our other mechanisms, like looking at somebody's history, we don't have all that additional context of what they saw on the screen when they ran those commands. But with Tlog and session recording, you do get that additional context. So Nate mentioned looking at what was happening at a certain point where your machine was having problems. We've all had that experience where a user says, I ran the command, but it didn't work. And you're like, well, what was the error? And that is difficult to obtain from the user who may not know what is important in the error. But with session recording, you just see exactly what they saw.
Right.
So
Right. This way, you're not parsing logs to try to figure out what happened. You can literally see what the session did. You can see exactly what the user saw, which is actually really, really handy.
right. So why don't we transition to the second half of the show? Don't forget to mash that like and subscribe button. In the second half of the show, we're going to be talking about several more security technologies, right? So we're going to start with system-wide cryptographic policy, and then we're going to briefly mention SELinux because like we've done so much on SELinux over the years. So
You don't want to do SELinux again?
not to the same depth we've done it before because we've done an entire show on it, right?
True.
About AIDE, the advanced intrusion detection environment, and
Yep.
then Nate, you're going to cover fapolicyd, which is
Yep.
application allow listing. And then if we have time, maybe we'll do a sixth, a bonus, and talk about firewalling. But that we'll see if we have time for that one.
Everybody loves firewalling.
All right, see you in a moment.
Folks who watched last week's show should be very proud of me. I got the right video this time.
Yeah, and Nate's doing all the producering today, so thank you, Nate. So security. So we're here to talk about
Important, totally important stuff, right? And like anyone who's worked for more than a minute in an operations role, hopefully we're not talking to folks who are unaware of this, but security is important. It's really important. And you've probably had arguments with either with security people or with end users or both about where the right level of security is, right?
Yeah, and the technologies that we're covering today, as I mentioned at the beginning of the show, are all included in RHEL. In fact, a lot of them are even enabled by default, but you may not have run into them because they just kind of work. Or maybe you did run into them, but you didn't understand what was happening. So
And
that's why we cover them a little bit more today.
many of them that are not enabled by default could easily be enabled by those OpenSCAP policies we talked about in previous episodes. So if you're curious about those, go back and look at them. You'll see a lot of references to a lot of the stuff we're going to talk about in this show.
So now is the time where if you're a live viewer, you can ask questions in the chat. If you're a deferred viewer, please feel free to leave us a comment. Nate and I do monitor and respond to comments as well. So let's next topic, which is system-wide crypto policy.
Yeah.
All right. So real quick, you'll notice what's my prompt there, Nate?
Whoa, are you on a RHEL 10 beta machine?
I am, because I live on the edge.
Live on the edge, man.
Red Hat Enterprise Linux 10, it's coming mid 2025. Beta is already released, but I figured it would be a nice way to live on the edge a little bit here at Into the Terminal and talk about some of these topics that are also included in RHEL 8 and are also included in RHEL 9 and are also going to be included in RHEL 10 as we see them here in the beta. All right, so one of the things that we started shipping in Red Hat Enterprise Linux 8 is a technology called system-wide cryptographic policy, or crypto policies for short. And we can take a look at which one we're running by default. All right, so update crypto policies -- show. That shows you the named crypto policy that you're running. And there's one called default, which is, guess what? The default. So on your Red Hat Enterprise, I know it's crazy. Red Hat Enterprise Linux 8, 9, and 10 beta. If you just take a look at this, you'll be running the default. The idea behind crypto policies is that there's a whole bunch of cryptographic libraries that are used by various different applications, right? We just saw Nate use SSH. Well, that uses cryptography libraries. The web browser uses SSL. That's cryptography libraries. You might use something like Kerberos, which has some cryptography stuff built into it. You might be using other TLS encapsulated services, right, which is more transport layer security, which uses different cryptography libraries. And we learned the hard way a while back that when one of these has a problem, it can be really bad. I'm thinking specifically about Heartbleed. So you may remember Heartbleed was a bunch of web servers out there in the world had older cryptography ciphers enabled by default, and they were no longer considered secure. And yet the web server was configured to offer those cryptography ciphers for people connecting. And so you could connect and be like, hey, I want a SSL 1.0 connection. And the web server would be like, look at its configuration, be like, oh, yeah, that's cool. Here, let's do that. Even though that was not a really secure cryptography cipher to use anymore. So back then, what we did was we ran around and we started looking at all the configuration files for all the different services and had to figure out which ciphers were and weren't allowed and customize our service configs to decide which should and shouldn't be allowed. And that's actually what was the spark for system-wide crypto policies. Wouldn't it be cool if we could have a central place to decide what ciphers were and weren't allowed for all the applications running on our machine?
Listen, Scott, you can't make systems administration too easy, because then anybody will be able to do it.
Yeah, well, that's never a problem. So, so we collected that together, and we actually compile all the applications that come with Red Hat Enterprise Linux against this library. So that when SSH is doing SSH encryption stuff, it actually does it by checking against the crypto policy to figure out what the cipher being used by SSH is permitted or not. And if it is permitted, then everything happens as one would expect. But if it's not permitted because it's too weak, then SSH is told no, and then SSH does something with that no. And so a couple of weeks ago, we did a show on SSH, and we talked about public-private key authentication. And I mentioned at that time something very obscure like, oh, if you're using a key that you've pulled from a really old machine, it may not work anymore on newer versions of RHEL, but I didn't really tell you why that was the case. And it turns out crypto policy is why that's the case. So if you try to authenticate with an old weak key cipher, the SSH daemon will try to grab that cipher library, and crypto policy will actually tell SSH no, and then SSH goes back and tells the user no. And that's how it all kind of works. But what happens if you want to enable those older, less secure ciphers? So we can change the system-wide crypto policy to permit that behavior. So we could do
Scott,
an update.
The answer is don't.
Well, yes, however.
No, the answer is don't. This is your security personnel talking. Don't.
Yeah.
No, realistically, we get it, right? There's cases. There's backwards compatibility to think about. There's reasons you may have to do this.
Right. And this actually happened when we first rolled this out. Firefox is another one that uses crypto policies by default. And turns out that you would connect to like different web servers. And if that web server was offering a less secure cryptography algorithm, Firefox would be told no, and the user would actually not be able to connect to the web server that they're trying to transfer data from. And within Red Hat, we had this service that was really old that we used for different things, which has now been updated, thankfully. But a whole bunch of people were refused connections to it when they started using RHEL 8 machines. And it's because their Firefox was refusing to make those old TLS connections to that machine. And so we had to like set their policy to legacy, and then it would permit those older ciphers to be used. All right, so when you change the crypto policy, you'll want to reboot the machine because the applications that get started up, they need to have fresh copies of these libraries. And so like if I did something now, like I started Firefox fresh, it would actually use the legacy policy. But anything that's already running, you would want to restart to also use the legacy policy rules. So that's why we recommend a reboot whenever this happens.
All right, you know, in cases like, oh, my web server, right? it's probably good that just switching the crypto policy doesn't go like, oh no, your web server's out of compliance, and just kill it, right? That would be a bad thing. But if you were to start Apache right now, it'll use whatever you've set it to. So yes.
Right. So whenever you set it, the recommendation is to reboot. So legacy will enable older ciphers that are deemed less secure. It is more permissive than the default policy. And then we have the opposite. We actually have one called future, which is more stringent. And future, it can have some weirdness. Like generally today, if you make SSL certificates, they're going to be 248-bit, 2048-bit ciphers used for those SSL certificates. But future policy requires them to be 3072 bits. So moving to future could like very easily break some of your SSL configuration, because that's not kind of the default for today, right? It's for what we think will be the default in the future.
Just
But
make all your keys 8K, you'll be fine.
if you want to check yourself against what we think is the future of these, you could set it to future and see where things are coming off the rails, and then you know what to change over time to get there. All right. So I said I changed it, but let's also just verify that I changed it with the show, right? So that's set. And that's how you manipulate crypto policies. I'm going to set mine back to default because I like default. All right. And because I didn't actually change anything, I set it to legacy, then I set back to default. I don't have to reboot because I didn't change the settings. There's more crypto policy stuff too. Like you could say, well, I like default, but I have all these SSL certs that are 2048 bit ciphers, and I need to keep them. So, or I should say future.
Right.
These older ciphers that I need to keep. And so you can actually go in and change individual configurations for what ciphers are permitted and what strengths are permitted through additional configuration files with the crypto policy. We're not going to get into that today, but in the show notes after the show, I will make sure to put a link to the Red Hat documentation that actually walks through doing this step by step, if that's what you're interested in.
I think we've got a lab too on that, on modifying crypto policies. I thought I saw that while I was researching for today's show.
That is actually true. So we have two labs. One is called Configuring Crypto Policy, which kind of like walks through this. It actually sets to future. You break your web server, and then you create new SSL certs, and then you fix your web server by actually upgrading its
right
certificate technology,
which is the right way.
Yeah, and then there's one called customizing your crypto policy, and that's actually doing lower level customization, choosing what ciphers are permitted and what strengths are required. So, Nate.
Yeah. Next on the list is SELinux, and we already kind of mentioned that we weren't going to go too deep on SELinux. We do have, I think it was episode, 102? I had it in the notes here somewhere. Yes, episode 102. We went kind of deep on SELinux. Maybe not deep, but we did cover like a whole episode of SELinux. So if you want to go back and watch that, I don't know. We didn't really have a demo prepared for SELinux other than showing its status. Do we want to do that?
Yeah. So, I mean, SELinux, we always talk about having SELinux on and enforcing, and you can check that status with SE status, right? It's right up there at the top. SELinux status enabled. I like SE status. Nate and I were debating before the show start. Nate, what's your go-to tool?
I like get enforce only because typing it and saying it at the same time. Because it just gives you a literal like enforcing or not, right? Enforcing permissive or disabled. Less to parse through if you're just trying to find it quickly. However, SE status obviously gives you that, but gives you more, right? So I guess it's really just a matter of preference. We had actually made a dynamic shell prompt at one point that had some bash scripting in it that would use get enforce. And if it was set to enforcing, it would actually put a note in the bash prompt that says SELinux is enforcing on this machine. It just had like an E or a P or whatever based on what it was set to. So that's mainly why I'm so familiar with get enforce, because I used that a lot to make that shell script work. But it was kind of fun, right? Because someone on your web team logs into one of their web boxes. They're like, is this one of our newer machines that has it enforcing, or is it on one of the older permissive machines? It's right there in the prompt. It was really handy. During that transition time, obviously our goal was to get away from having them permissive, right? So, but that was part of the growing pains. Is it on or not?
And I think that's the first hurdle to get over, right? Making sure that it's turned on.
Right.
The other thing is you could see in the SE status, so enabled or disabled is there. We also have the current mode, which is enforcing or permissive. And then the other thing I like out of it is it gives me the policy name. So this isn't really important for most people because they use the
Right.
defaults. And the default is one called the targeted policy, where we target specific types of applications. Like containers have some SELinux wrapping. Apache stuff has SELinux wrapping. Other network services like NFS or Bind have SELinux wrapping. But if you're in a more secure environment that actually uses customized SELinux policy enforcement, this is how you can tell like what name of policy you're using. So what's configured on the machine, and then also there's a version. So as you start to make changes to your policy, you can see what version is running on this machine as well. So that's why I like the SE status, because it gives me that more detail, and I'm a super nerd about SELinux. All right. So if you're interested in SELinux, watch the episode, like way more in depth. In fact, we've covered it a couple times on the show. So there's lots of SELinux content if you're not already familiar.
We'll try to make sure there's a link to that show in the notes for today's episode.
Yep. So our next thing that we're going to cover is AIDE. So this is the Advanced Intrusion Detection Environment. And to get it installed here, I just did a DNF install AIDE, which installed the AIDE RPM from the distribution. And then what I did was I did this command called AIDE-init. And so what AIDE does is it creates a database of a whole bunch of metadata about the files on your machine. Because typically if someone unauthorized accesses your machine, they want to do things like change settings to permit themselves more access to the machine, or they might drop a rootkit or other tools on your machine so that they can use them later. So what AIDE does is it creates this database of what your machine looks like today. And when I did the AIDE-init, that's what created that initial database. And right now, I'm not using it. So I'm going to go over to var libaide. Right, and you see that AIDE new GZ, that's the initial database that I created. And so what I want to do is I want to transition that one to be what AIDE actually is configured to use. So I'm going to move AIDE new GZ to aid.db.gz. All right, so I just rename it because in the configuration file for AIDE, and I'll show that a little bit later, it says when you're doing things like checks, this is the database name to check. And so it's called aid.db.gz. All right, so I'm going to do something on the system. How about I install some software? So I'm just going to install a web server. Well, now that I've installed some additional software, I've dropped files around in my directory structure and maybe updated configurations like the etc password file now has a new user in it for the Apache daemon. So I've gone around, I've changed a whole bunch of stuff. And I can do a aid --check. And what it's going to do is look at my current state of machine and compare that with that database that I put into place earlier. And then it's going to produce a report of the differences between the initial database that I have stored and my file system as it exists now. And it's going to take a little while for this to run, but it'll produce the report and publish it to the terminal here. So Nate, have you ever used AIDE before?
I'm aware of AIDE. I've used tools like AIDE. I've never used AIDE in production. There was another one called OSSEC that I used, OSSEC, which was another host intrusion detection system. It kind of had some of the features of AIDE, some of the features of the next tool we're going to look at, and wrapped into one. Right. It also had like a blocking mechanism that it would watch logs and block things. It was a really neat tool, but a lot of that is built into RHEL now. You don't need a third-party tool.
Yeah. All right, so my report actually exceeds the scroll back, but what we're looking at are like all the files that have been added or directories that have been added to the machine. So AIDE produces this list comparing what we have now with what's in the database. And then it goes through and actually gives you a little bit more information. So not only were these files added or these directory added, it'll also tell you about things that have changed. So we can see that like Etsy crypto policy backends, OpenSSL cnf.config was changed. And these files, things that are in the like MCI, capital H or I or whatever, that's actually telling you the metadata that we track about that file or directory. What exactly has changed? So period means nothing. This metadata thing that we track has not changed. The other things like MD5 checksum, content, I don't remember what I is, hash, that stuff has changed. So we got our list of new things that we didn't see before. We're now getting our list of things that have changed. And then it goes a little bit further and gives you more details about those changes that have happened to the machine. All right, so when you are using AIDE, the idea is that you kind of like have your machine set up in a steady state, and then you build your AIDE database because you're like, this is what I want it to look like now. And when I come back and I do checks, I want to see how it's changed over time.
Right.
So I just installed the software. I purposefully installed the software. I expected all those changes because I installed the software. So I'm going to update my database to say, this is the new state of the machine that I expect. Right. So I'm going to do an AIDE -- update. All right, so this will take a little bit of time, and it's basically going through and building a replacement database of the current state of the system, and it's going to put that in the varlib AIDE directory where it stores the databases. And we'll
Now,
take a second.
I presume that you can, because there's things on your system that will be changing depending on the use of the system, right? Not most systems are not 100% change free, right? In fact, I'd argue that no system is change free because logs, for example, are writing all the time. So, or if it's a web server where new content might be uploaded frequently, right? Or a database, right, where the database files are changing. So there must be some way to make exceptions for don't bother tracking this file that we know will change.
Indeed, and in fact, when we talk about the config file at the very end of this block, I
Oh,
will show you how that's configured.
see, now
All
I'm
right,
the one predicting the future.
that's
It's almost
right.
like I have the notes in front of me. I could have looked.
What we just built with that AIDE update was an AIDE new GZ. All right, so that's the new database. And if I'm happy with this one and I want to make it the now snapshot, the now accepted snapshot on my machine, I'm going to move AIDE new to be called AIDE GZ. All right, so I'm going to overwrite the old one because now this is the new accepted state of the machine, right? All right, but so now I get everything to my accepted state. I build my AIDE database, and now things should be pretty steady. I'm not expecting anything, so I'm just going to let it be. And then somebody's going to come in and maybe do some stuff like I don't know. They add a file, and
If only they
maybe
were all so obvious.
maybe they go into a config file and they make a change like
You've been pwned.
oops. Yep. All right. So at some point in the future, I come back to this machine. I'm like, hey, what's different about this machine? So now I can do an AIDE -- check. And what we should see is there's a new file called user bin haxor tools, and the Etsy issue has been modified. And because it's not like a giant pile of files that were installed from an RPM that I was expecting, this should be a much more targeted, hey, I should probably go look at these things because this is
Right.
not what I expect the state of the machine to be.
And this is perfect for things like, a hacker comes in, drops down a rootkit, or a job that runs frequently, or something, right? It should show up in this AIDE check.
All right, so there's my thing, and we get a little summary up here, right? So we got one new added file, we got 4 changed things. So Haxer Tools is my added file that changed things.
It got your Vim info file.
Yep, and I edited stuff.
Yeah.
And the user bin directory was updated because it now has a new file that is a component of it. And then it goes in and gives me a little bit more detail on like what about the Etsy issue was changed, right? Its content changed, but we also see things like its modification time stamps,
Yeah.
its size, and we actually capture several different checksums with different algorithms. So we can see that those have all been updated. All right. So the last thing is, what if I expect a change or I'm not interested in tracking a change somewhere? So in the Etsy aid.conf, crazy file name, this is what, let me go to the top here. This is what is the configuration file for AIDE. And so we see things like, where's the directory where we store the AIDE databases? What's the AIDE database name that I want to run my checks against? So things like that. And then as we scroll down through the list, right, I mentioned that we track a bunch of metadata about the files. Well, here's the things of metadata about the files that
There
we
you
track.
go. So what's I?
Going to make me look.
Yeah, well, you didn't
I know.
know. inode. There you go. So the inodes have changed.
All right. And then down a little bit further, we get into the this is the list of directories where we want to go through and capture all this metadata about the files and subdirectories. And so the reason that root's Vim info got captured is because /root is the normal collection of information. But you can see that user source and user temp are exempted from being captured. So you could do like var could be exempted or var log could be exempted because those files
Right.
change. Not really interested in knowing that those files change.
Or temp, for example. Yeah.
Etsy, it's like, well, you're going to go in and make changes to your configuration files. Maybe we don't care as much for those. And so here for Etsy, instead of tracking the normal metadata, we only track the perms metadata. If we scroll back up in the file, we can see what actual things perms means. It's basically a collection of those pieces of metadata that we're interested in. Right. So if you have an exclamation mark, it means don't bother tracking this thing. And then you can specify individual files as well that you want to make sure are checked, because Etsy as a whole is perms, but maybe Etsy group, you want the normal metadata tracking for that one file. So you can get really detailed in your AIDE conf if you're interested.
Cool. It's a really useful tool. There's also you might have watched that demo and thought, yeah, but that feels really manual, right? Now, obviously, there's ways probably to automate that, but there's also another tool. We're not going to show it today because it's a little more complicated and it's not part of our top 5. But there's a tool called Keylime, also known as remote attestation, which leverages AIDE and a remote server that they'll talk to each other. So if AIDE triggers something, it'll tell Keylime will tell the remote server, and then an admin can monitor that server, right? And you'll get an alert or something that you can then say, hold on, there's a system out there in the wild that's been modified, right? So really useful for, like, I don't know, machines running in the back of a warehouse somewhere, or like payment terminals, right? Like things that are going to be in the hands of people that you really need to be careful about what they're doing with them, right? So good stuff. All right, so the next thing we want to talk about is fapolicyd, and that's file. Why am I blanking? It's not file access, right? It's file. The fapolicyd. Blanking on the damn name. Anyway, attestation, is it? I don't know. fapolicyd is a nice tool that lets you do application allow listing with within your environment, right? So what it can do is it can build hashes and checksums and whatnot that it'll compare against executables or the packages they were installed from, and tell you if they've been modified. So this is another layer of defense against the rootkit type stuff that Scott was just showing with his hacksaw tools that he put inside a user bin. It is file access policy daemon. Okay, thank you, Scott, for looking that up. I don't know why I thought it wasn't access. Anyway, I have a quick demo here, so we can jump into my terminal session. And I've already got fapolicyd installed. Much like Tlog, the file you're looking for, or the package you're looking for, is literally called fapolicyd. And what we're going to do is we're going to look at the config file here, just by pasting it in there. And you can see that there's a couple of configuration options that are already in there. A couple that I want to call attention to are things like what user it's running as. That might be important for your particular use case. This is permissive equals 0. Sort of like SELinux, you can set it to permissive mode, and then it'll just log things when there's problems. But permissive equals 0, in fact, means that it's enforcing, right? So it's actually going to act on the things that we have in this configuration file. I also want to point out integrity is set to none at the moment, and integrity is one of the things I want to show you. So we're going to actually modify this right now and change integrity. So we're going to edit. Actually, let's just, instead of me trying to type all this out a number of times, fapolicyd is one of those things that's tough to type. We're just going to open it up in the best text editor, and down here where it says integrity. Now you might just say like integrity yes or no. That's not the case. You have to tell it what algorithm it's checking. And in the case of our example, we're going to use SHA-256. And to be honest, I'd have to dig to see what other options there are. So we're just going to save this, and we still don't have the daemon running, but what I wanted to do was show you a executable that we've pulled in from outside, right? So we're going to switch over to our rel user again. Right now, again, I could have done the SSH thing. My session's still being recorded, you might guess, because this is the same system I did our demo on earlier. But if we run cowsay moo, right? We have, what I did here is I went and got an external version of cowsay and put it into the home directory for rel. So this is not an RPM installed cowsay. If we look at this right here, you're going to see like, here's the package that I downloaded from the internet, and here is cowsay, right? So this is external, right? However, it's working. You're like, wait, we put fapolicyd on there. Why is it working? Because it's supposed to stop this sort of thing. That's because we didn't start the daemon yet, but I wanted to show that to you so you could see the difference. So now what we're going to do is we're just going to, instead of switching back to root, we're going to use sudo. Okay, and super secure password. Clear the screen again so you can see better. Now we're going to try to run cowsay again, and this time it's going to say, nope, you can't run cowsay because it's not in my list of things that are allowed to run on this machine. Right? So pretty straightforward, but you might say, but I want to run cowsay. Cowsay is a thing I put there for a reason, and I need to be able to run cowsay. Well, there's good news. You can actually add an exception for cowsay or for whatever you're running. So let me just grab this command here too. We're going to, again, run that through sudo. fapolicyd-CLI is the tool you use to interact with fapolicyd and tell it to do extra things, right? So we're going to add a new file to its known database of hashes, home rel cowsay. We're going to run that. And now if we look in the trusted file for cowsay, or not for cowsay, for fapolicyd, enter here. Oh, hold on. I hit up on accident. Make sure it didn't like break something on me. So now you can see we've got home rel cowsay in here, and there's a SHA-256 hash for it right there, right? So what that did is it made a hash out of the existing binary. If that binary were to change, it'll no longer match, right? And then it won't let you run it anymore. But if I run it now, let's just run cowsay again. Oh, I know what I forgot. You have to tell fapolicyd to update after you modify that database. So hold on.
So you're going to reload the daemon?
Well, I could reload the daemon, but there's a CLI command that just says update it from the known configuration, right? So now fapolicyd was notified, which basically says the CLI told fapolicyd, hey, refresh your database. And now if I run cowsay, it should work, right? So now we've got cowsay once again. Hey, Scott, did you know there's different ways? There's different models for cowsay?
Yes, I did know
There's
that. Thanks.
there's a
Apple.
bunch. I recommend that folks go check because I'm not going to go through them on today's show, but there's a whole bunch. You can make like Beavis say things instead of the cow. Anyway.
That's if like somebody puts executables in their home directory or like some weird spot.
Yeah.
What we put them in, like we install new RPMs. Does fapolicyd automatically block those, or how does it choose what
See,
is?
now you're the one that's not reading ahead because that's exactly what I'm going to show you next. So that integrity checking that I put in place, right? What that tells fapolicyd to do is to use the integrity checksums that come from the RPMs when they're installed, that is logged in the RPM database, to verify that packages you've installed through your package manager still match the checksums from when they came out the door, right? So we're going to use cowsay and more, bin more as an example here. So just to show you there's nothing up my sleeve, if we do more, you can see it executes, but I didn't actually give it anything to do. So it just says bad usage because more expects some command line arguments. What we're going to do is we're going to take the binary that we just told fapolicyd is fine, and we're going to replace more with it. So we're going to go sudo cp cowsay / what is it, user bin or just bin? Just bin, I think. Yeah, bin more. Okay. Now, obviously, we're doing it through sudo because a normal user can't replace more. It's not supposed to be able to replace more. That's exactly how rootkits. You want rootkits? That's how you get rootkits. Anyway. Now, if I try to run more, now we know more is cowsay. So if I try to run more and then moo, operation not permitted. If I just try to run more, operation not permitted because I replaced that binary. It no longer matches the checksum that came from the RPM when it was installed. So that's basically how that operates. If I were to put more back, it should start to work again. So there's a really easy way to put more back. A second here. That comes from the package util-linux-core. We're just going to do a reinstall on that package. And I think you could have asked RPM like what files have changed. There's an integrity check within RPM. We've probably talked about that in some other shows as well. All right, and now if I run more again, why is operation still not permitted? It should have replaced it. I swear I tried this earlier and it worked.
Do you have to update your daemon one more time?
I don't know. I could just restart it quick.
Well, not as rel.
Oh, you're right. Maybe I forgot to test this. There
we go.
So yeah, that's what it was. fapolicyd had to be alerted, I guess, that it had changed. So there you go. Great utility for, do I have a rootkit? Did someone put something in place where it wasn't supposed to? If I had put cowsay inside of user bin and then tried to run it, it would have given me the same operation not permitted. So even if I'm putting extra executables on the system, configured in the way that we have it here, it should stop both of those things from running. Either, RPM installed binaries that have been changed or binaries that I've sort of side loaded in place, right? So,
well, I think that's something that we probably have lost track of over the years. Like it used to be really common for users to install software in their own home directory to run for their own purposes. And over the years, I think that's gone out of style. And yet it's still possible and it can still happen. So,
absolutely. Yeah.
Yeah. So this is a way that you as the administrator can like enforce that will not happen, right? You'll only software that's packaged and stuff that people put in their home directories and tar archives, or they've built their own binaries or whatever, you'll eliminate because you're using application allowed listing.
And once again, I think we're out of time to talk about firewalling. What do you think?
I mean, we are, is there something small that we could talk about? Because like we debated doing a whole firewall show. Maybe this is the teaser for the whole firewall show.
Yeah, I kind of think we need a Firewall D show because honestly, there's so much we could go into. What I was going to talk about was firewall zones and how useful they can be, but I think that's a teaser. I think we just say, yeah, maybe next time we'll talk about. Probably not next time, but sometime soon we'll talk about Firewall D. What do you think?
Yeah, we'll put it on the pile of show ideas.
Yeah, yeah. I
I
like
know that a lot of
firewalls.
yeah, but like a lot of people are like, nope, not on my host. I just rely on the network guys, right?
Yeah,
So
so
why?
I've always gone with a defense in depth approach. Yes, you should have a network firewall. You should have an edge firewall, right? And there should be layers like onions from one to the next. However, a host-based firewall can protect you from, somebody's gotten past those defenses, or someone's used your web application or whatever it is that's remotely accessible on a particular host to get into your host, and now that host is the bad guy, right? So you want your other hosts to be protected from that host. And maybe there's not a network firewall in place to protect them from that host. Maybe there should be if you've got proper network isolation. But maybe you just don't want this web server and that web server to be able to attack each other, right? Host-based firewalls come into play then, right? And that's a really good way to get it done. Plus, I mean, the alternative is I've got a co-located machine which does not have a network firewall in front of it. And I had to depend on Firewall D to do things like set up zones to say, okay, these IPs are allowed to SSH in, but everybody else is not, right? So if you're in a case where you are like bare connected to the internet, that's a scary place to be sometimes, but your host-based firewall can really help there.
Right on. We did pick up a fapolicyd question from Billy. He asked what would happen with Python or Bash scripts. So I wonder if we could toggle back into your machine and do just a quick hello world Bash script in RHEL's home directory.
We can try. I think we'll be learning together though. So
What? You go off script. I don't know.
what could possibly go wrong? All right, here. All right, you got it. All right, good. Okay, so yeah, all right. Let's just make a Bash script. Vim hello.sh. So I'm thinking that this is probably going to work because the actual executable in play is Bash.
Yeah, I think you want to
Not
shebang
sh.
that bang.
Yeah, that was a typo on my part, not intentional, and not Vash either. This is not Trigon. Anybody get that reference? All right, we'll just like echo. Okay.
Oh,
So what?
You don't want the exclamation point with your double quotes.
Man, you see what happens here? Okay, fine. We'll just escape the exclamation point. How's that?
Good luck with that.
We're gonna find out. All right. I bet it runs. Oh, okay, so it didn't escape properly, but whatever. It did run. So yeah, I guess fapolicyd will not prevent it from running because, like I said, the actual executable in play here is Bash. So it's interpreting a bunch of commands through Bash in the same way that an interactive shell would, right? So ideally, though,
I think the same is true for as long as you're using like one of the system installed Pythons and not your own like private executable.
Yeah, yeah. As long as it's an executable that came with the distribution with RHEL, it should execute it. If you've sideloaded Python, then it wouldn't. But you might argue, like, what's the real threat here, right? Because you haven't put an extra binary in, you haven't sideloaded a rootkit, you haven't, modified bin ls to do nasty things every time you execute it. You've just made a quicker, more efficient way to run a bunch of commands you would have been able to run through Bash anyway, right?
Yeah. I would guess that the genesis for the question was, well, users also create their own things like shell scripts or Pythons. And like, it's great that we don't let them import compiled binaries or compile their own binaries. But what about these interpreted languages that they kind of do use all the time? Would that work? And yes, it works.
Yep. Seems like the answer is yes, it would still work.
All right. So next week, we'll be doing something. We will be.
Yeah.
Or, I'm sorry. No,
we won't.
That's right. Next week. So in 2 weeks, we'll be back with another Into the Terminal. We don't know what that looks like yet, so we'll figure that out on Monday next week. And we're closing out the year, so we only have a few episodes left for the year. Nate, we have a special episode planned for the end of the year, right?
Yeah, I forget what the topic was. We were going to do like a kind of a fun year-end show, kind of like we tried to do last year.
Yeah, I think it's going to be like never do this to Linux machines.
Oh, right. We're going to like try to break things.
Right. In non-fixable ways, right? These are like resume generating events that that you get to see done live.
Like when I deleted boot on that system live, and then we fixed it.
You got it back.
We did fix it. We did. That was pretty cool. I'm proud of that.
We're gonna have to do stuff that's like way worse than that.
Way worse than that. You'd think deleting boot was way worse, but no, I was able to fix it. Maybe it's just because I'm that good. I'm that good, Scout. That's what it is.
Clearly. I wish your manager would like give you a bonus or a raise or something.
I know. I'll have to talk to that guy.
All right. So see you in a couple of weeks for another Into the Terminal. And thanks for watching, everybody.
Folks, have a great one.